Hello everyone, it's nice to be here in Newark. Very cold today, but anyway. Every presentation has some cats in it, so I'll get it out of the way. It's it's down in the agenda as a how-to, but as I was sort of coming to write this presentation, I realised that I knew all of the how-to bits, but the how I was a bit shady on, so I've done a bit of research, and there's some theory in there as well. So, what is multicast? We've all seen diagrams that look a bit like this. It's a way of splitting out data so that you only have to send it once to multiple recipients, which is very good. Because, for example, BBC HD is about 15 megabits per second, and I looked this up on Wikipedia last night. About 16 million people seem to watch EastEnders. So if you try to unicast feed that to everyone, you'd need 240 terabits per second, which is just not practical.
A lot of sorrow.
Yeah, it's a lot of pain and Cockney anguish. So, yeah, the network starts to look more like that. You don't need a massive amount of capacity at the head end to feed it. Who uses it? Banks use it. They like to spew out share data and stocks and all that stuff in little UDP datagrams that flow around, and they can pick it up and do their magical microsecond share trading and all that crap. IPTV. If you ever watch the telly in a hotel, there's a good chance that you're actually watching it through multicast. So I've put a couple of little graphs up. The one at the top is the Olympic closing ceremony that I watched at home and then thought, oh, I'll save the graph, you never know, it might be useful. And the one below it is, at the start, you can see we've got about 500 meg there. That's all of our normal... Oh, I should probably add a little bit of background. One of the bits of work I do is for the BBC, BBC Research, where we multicast out a lot of the channels. And the 500 meg bit is 24... Well, is this normal output, which you can see down there, around 100 meg, plus 24 HD channels and 24 SD channels that we put on for the Olympics. And that drop is where they turned it off. And ignore the blue bit. And another use for it is gaming. You know, everyone joins the group, all the games get the data, very little effort, everyone's happy. Two types of multicast to really think about. ASM and SSM. ASM has been around forever. It's pretty old. It's had a /4 set aside for it. And in IPv6, sorry. I think we'll turn that off.
Don't mind a drink.
Yes, she needs telling to that one. Anyway, so IPv6 has a /8 for multicast as well. And actually on the wire, you've got a group of MAC addresses, which you take some part of the... You'll note that there's 24 bits of group there, but there's more than 24 bits of V4 space reserved for it, more than 24 bits of V6 space reserved for it too. So you do reuse MAC addresses, which sometimes causes interesting fun, but it will come to that. Good things about ASM. Lots of devices support it, which is great. Even some of the fairly old stuff, even though it might need a little bit of help from the router or whatever. And anyone with a 16-bit AS number already has a /24 of this space that they can do what they want with, which is good. You just put your AS number in the middle and use the groups as you see fit. You actually don't have to stick to those, but we don't want to tell people that because they shouldn't be naughty. Bad things about it. ASM is kind of insecure if you don't secure your network, because it doesn't sort of work from a source and destination point of view. Everyone joins the group, so if you haven't secured your groups, someone else could push a packet in that would come out to everyone else that subscribed to that group, which, if it's IPTV, for example, would screw it up quite badly. And it's vulnerable to denials of service. Imagine, if you will, 1 million packets per second of unicast. You know, we've all had denials of service like that. But then imagine that it's going to a load of people subscribed to a multicast group. If your network doesn't get unhappy, then your end users probably will. So, if you want to watch TV through it, I've drawn a little diagram here. Step number 1. Let's see if I can actually find my notes. The streamer starts streaming. It joins a group and starts just spewing it out. Its local router receives this and reports to the rendezvous point in the middle there. The rendezvous point is sort of the brains of the operation. It coordinates what's joined onto where. It tells the rendezvous point that I have this group. This station is in this group. So that can sit there quite happily. The data sits there going between the source and the first hop. It doesn't go anywhere else. That's great. The destination decides it wants to watch telly. So it also joins the same group. It's the same process as for the source to join the group. It talks to its router, which talks to the rendezvous point, says I want to join this group. The rendezvous point sends a message back that says this source station is also in the group. So then the routers do a little bit of magic here. It's quite intensive thought process for the routers, I think. So that router then talks up the stream to the source router and through PIM, Protocol Independent Multicast. It's another thing to look up on Wikipedia because it's a big topic. There's a massive set of RFCs about it. But anyway, through PIM, that builds the tree and the data starts to flow. Gets a little more complicated when you want to do it between ASs, as you might if you want to appear with the BBC, for example. You need some more protocols, MSDP, MBGP. MBGP is not actually a different protocol. It's just another address family within the existing BGP sessions that you might already have. And MSDP is for the rendezvous points to talk to each other so that they all can coordinate with what's going on. You do end up with some quite large lists of sources in these things, so I think the scalability is possibly limited, but not that many people use multicast on the big internet, so it's not been a problem yet. As you can see, I've got a little bit of output from my router about this. This is my peering with BBC R&D. You can see we're using a little /20 for our research network there. And the second line, that's the group for BBC One. And you can see this is on my network, but it knows that the source, 132.185.236.77, that's unicast address. And then there's a multicast group next to it. It knows the rendezvous point, which is the BBC's router, the AS number, how long it's been up, and blah, blah. Inter-AS, it looks a lot like this. So you have the source connected to a satellite dish, spewing it out to the router, which also happens to be the rendezvous point, just because, you don't need that many boxes to do this stuff. It goes into LAN app, which I've made purple because we've just used extreme equipment. It actually goes onto a dedicated VLAN, which is separate from the normal peering VLAN, because, well, there's a couple of reasons. One of them, sort of security, and secondly, it is sort of passive to multicast at the moment. It doesn't attempt to sniff the PIM yet. So we were looking at it, but it would need to work with VPLS and so on. It's quite a deep rabbit hole that we need to look down. So my router sees it. My router's got PIM adjacency with the BBC's router. My rendezvous point talks to the BBC's rendezvous point. So when me, destination, sat at home, I want to watch the telly, my join goes to the rendezvous point. That consults its table, says that group's over there, talks to that router, and the data flows. It's like the previous diagram, but with a couple of extra protocols thrown on top. This configuration will let you, if you've got Cisco network and you want to pair with R&D to get our multicast streams, then talk to me. Please don't do it if you're an international operator. We don't have permission to let you do that. But if you're in the UK, then this is fine. Inside your network, you want to have PIM turned on. There's sparse mode PIM, and you also may notice you get an option for dense mode PIM. Dense mode likes to sort of flood and then prune back if you don't want the data, whereas sparse mode waits for you to want the data before it sends it anywhere. And that's the one I generally use because I don't want a load of multicast coming up my home connection. On your routers, you need to configure a rendezvous point within your network. That can be, well, in Cisco LAN, that can be just about anything. You just point it at it, and it will just work. On your rendezvous point, you will need to configure an adjacency with the BBC's rendezvous point. That's one line there. On your peering router, if you're on LAN app, you will need to ask us for VLAN 5. If you're on links, I believe it's a separate port, but I don't think it costs anything, am I right? Silence. I think that's the case. So, yeah, you want to configure your port a bit like this. The BSR border bit on the interface statement there, because PIM swaps a lot of state around inside your network, but this isn't all stuff that you want to leak out. You just want to form a basic adjacency outside the network, so you need to tell it, this is the edge of my network, please don't leak everything out of there. And then you need IP PIM sparse mode on there just to make the PIM happen. And you'll need BGP with the multicast address family on there. I always stick no BGP default IPv4 unicast in there because that just makes your config neater, so if you aren't using that config line, you might want to look into it. Right, now, SSM. The good thing about this is it's a lot simpler and it cuts out a lot of the extra bits that I've just told you about. So you don't need MSDP, you don't need rendezvous points, and I don't think you need the multicast BGP aspect of it either. Because we all have a unicast routing table anyway, so it just uses that to find the source. And it's actually more secure from, if you want to watch telly or whatever, then the other people that are joined to the group can't send packets into your stream without you wanting them to, because they just can't do it, because you are joining. You've told your router where to get the stream from. But this may be a disadvantage depending on what you want to do. Obviously, because you're soliciting it from a source, a specific source, then you're not going to get the sort of multiple shared sort of soup aspect of the ASM. And it's also not quite as well supported. It has its own address space, which is a subset of the ASM space. So you can, if you remember, 224/4 was the ASM multicast space. They've carved off a /8 for SSM, and they've carved off a little bit of V6. You will have noticed probably that X is not a hexadecimal number, but there's an RFC covering what the X means, and it's quite long. Read it if you want to. IPv6 multicast. Right, I normally advocate IPv6. I think it's great and everyone should use it, and this IPv4 stuff should just die in a hole somewhere. But IPv6 multicast is quite hard to find support for, because a lot of the equipment that I use, for example, is Cisco 3560s, and they don't understand it at layer 3 at all, and they only have a sort of basic knowledge of it at layer 2, I think. So in my lab, there's not a lot I can do with IPv6 multicast. But apart from that, all the principles are pretty much the same as with v4. So once you've cracked it in v4 land, then in 10 years' time when we have vendor support on everything, you can just go with it. And questions? I've missed out some of the layer 2 stuff, unfortunately, because I kind of did the slides in a bit of a hurry. What you might find is if you plug a multicast source into a switch that's just sat on its own or that's not connected to a router that's got PIM enabled, is that it just floods the multicast, even though it's an expensive switch, and you're thinking, why the hell is it doing this? I've paid a lot for this. It's meant to do it right. But it needs help from the switch or from something called a querier just to sort of build its internal tables. But does anyone have any other questions? Have I got anything wrong?
Go. Greg.
Thank you. Greg Choules, 3 Mobile. I just wonder if I came across IP Multicast a long time ago, and it doesn't really seem to have taken off that much. I mean, I know the Beeb use it, but other content providers are tending to sort of distribute their content to the edge of the network, closer to the clients, rather than centralize the content and make the network deliver it for them. I'm just wondering which way the world is going to jump on this one. And personally, it makes sense to me to do IP in multicast, but it seems like one of those good ideas that has never quite taken off globally.
I think it's used a lot by people inside their own networks. Very, very little actually crosses the border between ASs. I imagine it would be a good thing for CDNs to use to populate caches and so on, which then spew out into unicast. And the way the world is going is more sort of on-demand programming than I must sit down at 8 o'clock to watch this show. So, yeah, you can push stuff to the edge with multicast quite easily as well, because you don't have to have support on the CPEs and all that. And then your customers can just pull it off in their own time. Oh, would anyone like to peer with the BBC? Are you on non-app? Please join.
Okay, any other questions for Tom? Okay, thank you, Tom.